Welcome to Let's Learn. We are taking the mock interview of Shubham Handibak. Okay, let's start from non-technical. Okay, can you introduce yourself, Shubham? In the introduction, you have to
Uh,
tell what is your name, means your parents' name and their profession, and if you have siblings and their profession, and the year you graduated and your aggregate percentage. Only this much.
this was only I have to
Yeah,
say.
yeah.
Miss, no, we should not tell about the extracurricular
No, no,
activities
no, no.
or any
Only
project.
no, no. Only this much. Only this much.
Okay. Good afternoon, sir. I am Shubham Handibak. I have completed my BTech from Vishwakarma Institute of Technology, Pune, and till the eighth semester, I have pursued 8.557
Mm-hmm.
CGPA,
Mm-hmm.
and my dad is teacher and my mom is housewife. So, and I want to be an chief engineer in my life. That's all. And I'm alone for my mom dad.
Okay. Year you graduated.
I have graduated in 2023,
Okay.
before two years,
What is
2 years.
your aggregate percentage?
My aggregate percentage are 8.57
Okay.
CGPA. Sorry,
In percentage, how much?
in up to 79%.
Okay. Okay. And okay. Let's. Why do you want to join merchant navy?
The one of the reason is uniform. It's an uniform job, and I love uniform jobs. That's why in the seventh and eighth, also I have joined the RSC. I was the leader of RSC, and I
Mm-hmm.
was more attracted toward the uniform job. And one of the reason is it's an high paying job,
Mm-hmm.
and it is more adventurous job instead of just sitting in front of computer and doing the task for 6 and 7 hours. That is,
Mm-hmm.
I think, for me it's a boring thing. So instead of that, this is more adventurous job, and these are the reasons why I want to join merchant navy.
Okay. What is your height?
My height is 160 centimeters, sir.
150.
160 centimeters.
160 centimeters. Okay. Tell
Yes.
me that in kilometer.
That will be up to 0.00169 160 kilometers.
Correct. And uh, then one second. What is the president name? What is our president name?
Uh, our president is Draupadi Murmu.
Okay. India is surrounded by which sea and oceans?
At the west, that is Indian Ocean, and at the east, the Bay of Bengal.
Hmm.
At the west, uh, Arabic Sea.
At the west, it is at the east it is Bay of Bengal. At the west, it is Arabian Sea. At the south, it is
Okay.
Indian Ocean.
Indian Ocean.
South is Indian Ocean. No, you told west. So okay.
Okay, okay, sir.
Okay. Where is Qatar situated?
No, sir, sorry, sir. I'll definitely brush upon it after the interview. I don't.
In the
Yes.
Iran that side. Okay.
Okay.
And what? Where are you from? Your hometown?
Uh, I'm from Aklus, Maharashtra.
Maharashtra. What is the Tamil Nadu capital?
Mm, uh, sorry, sir. I don't.
Chennai. And what is the Kerala capital?
I think Thiruvan,
It is Thiruvananthapuram, right?
Thiruvananthapuram.
Kerala, Calicut. Calicut it is, sorry. Calicut.
Yeah, Calicut.
Okay. Uh, then, of our financial minister,
Financial Minister, uh, I think
Nirmala
Financial
Sitaraman.
Minister, Nirmala Sitaraman.
Okay. Name five country of Europe and their capital. Wow, this is very okay.
I think Russia, then France.
European country में
Uh,
Russia. It will come.
uh, yeah,
No, I don't think so.
it's some of the part is in Europe and some of the part in
Ah,
Asia also.
yeah. Okay. Tell other.
Then Spain,
Hmm.
uh, then Germany,
Hmm.
Netherlands,
Hmm.
uh, uh, then Austria.
Hmm.
Uh, these are the some countries
Okay.
which are in India.
Okay. Who is our vice president?
Vice Jagdish Dhankar.
Yes, correct. And then wait. Difference between the Independence Day and Republic Day.
Um, the Independent Day is uh, uh, basically at that day we get the freedom, and at the Republic Day basically India have they have accepted the constitution.
Hmm.
I haven't prepared that. I
Hmm.
have to prepare that.
Okay. One liter is equal to how much weight?
1 liter of water or
Hmm.
what?
1 liter of water has mass of
One-
how much?
1000 kg per meter cube.
1 liter is equal to 1 kg.
1 kg. Okay.
Okay. Then these all were asked. In FIFA World Cup final match, who won?
Right. Don't you see the sports matches? I think that aspirant whom he had asked the question, I think he might say that his favorite uh,
No.
sport might be football. That's why
No,
he might.
it is not like that. Means at that month only this World Cup final match might have held. Means Real Madrid, the Messi team has won. No, Messi team is Real Madrid, I guess. I also don't watch football. Name some northeast states.
Uh, Assam,
Hmm.
Mizoram,
Hmm.
Manipur,
Hmm.
Meghalaya.
Hmm.
These are the some states.
Okay. Uh, you just be prepared for whatever current affairs is going on. He can ask anything actually in this part. And this conversion is also very important. Means centimeter to kilometer. You told correctly. Uh, and in some people they have asked what is how much will be the feet. In feet, your height how much it is? In 160 centimeter. No, in feet how much it is?
That will be 5.54.
Yeah.
So if you want to convert the centimeter into the height, into the feet,
5.3 it is. 5 point not 5. 5.5 not. 160 centimeter, right? Divided by 30 you do.
Hello.
Hello, 5.3 it will be, not
Where
5.5.
is it? I don't know who is calling.
Your height will be 5.3. 5.3 feet.
5 point. Okay, because the thing is that I have heard that when if we have to convert the centimeter into the feet, we need to multiply. If my height is 160 centimeter, then 160 into 0.0. If we multiply it by 0.032, then it will be converted into the feet.
30 centimeter
And
is equal to 1 feet, right?
30 centimeter is equal to 1
1
feet.
feet. Then your height is 160 centimeter. Then it will be 5.3.
Okay.
So like that.
Actually,
Yeah, just cross check later. You can know.
okay.
No,
Centimeter equal to
yeah,
1 centimeter equal to how much feet?
no, you don't check like that. 1 feet equal to 30.48 centimeter. Where this data we show you. Oh, sorry. Okay.
30.4.
Then wait a second. Then I will come to technical part. Okay, this question is there. Okay, explain centrifugal pump and tell how the pressure is created in discharge side.
Basically, in the centrifugal pump, the motor shaft is connected to the pump shaft, and pump shaft is connected to the on the pump shaft. Basically, the impeller is mounted either by threaded connection or key connection or press fitting over the shaft. So when the uh, motors start rotating, with that impeller also start rotating inside the casing. And basically, when the impeller starts rotating, it creates the vacuum pressure due to which the fluid is gets sucked. and impeller imparts a centrifugal force on the pump fluid. That's why the fluids get displaced radially outward direction. That's why the vacuum or the white space is created near the eye of impeller, and due to which the fluids get sucked. And the casing, the casing which is used is volute casing, so it is having gradually increasing area. So near the suction side, the area is less. So that's why the kinetic energy or the velocity of fluid increases and the pressure decreases. But near the discharge side, the area of casing is more. That's why basically kinetic energy of fluid or the velocity of fluid decreases and the pressure of the fluid increases.
Okay. Okay.
This is
Then
how the centrifugal.
okay, boiler mounting. Can you list the boiler mounting?
Yes, boiler mountings are blow down valve, then pressure gauge, uh, air vent cock, then safety valve, then steam stop valve, feed check valve, scum valve. Uh,
Okay.
These are the and gauge glass.
Totally, how much you told? 7.
Yeah, I think more than 7. I think.
Okay. Total there is a 10. It is there. Can you name again? One second.
Okay. Uh, blow down valve,
Huh.
then pressure gauge,
Mm-hmm.
then air vent cock, then steam stop valve, then safety valve, then gauge glass, feed check valve. Uh, these are the safety.
Fusible plug. You missed it, right?
Visible plug.
Water
Okay,
blow down
visible
valve
plug.
you told, huh? Water blow down valve.
No, water blow down.
Water blow down valve. And scum
Water
valve you
blow
told.
down. Yes, come on.
Scum valve you
Like
told.
I forgot it.
Low water level shutdown. That you told.
No, I
Okay.
haven't.
Only these only you may missed. You told actually 7. 3 you missed. Okay. Then what is CC?
This is basically cubic centimeter that tells about the power, and basically CC is the the volume swept by all the pistons inside the cylinder during the one stroke.
Yeah.
That its unit is cubic centimeter
Mhm.
and also liter. So 1 liter is equal to 1000 cc,
Okay.
and basically this is cubic centimeter is equal to pi by 4 d square into L into K, and K is the number of cylinders, and it gives us an power output.
Okay. Can you differentiate between 2-stroke and 4-stroke?
Yes, sir. In the two-stroke engine, the thermodynamic cycle completes in the one revolution of crankshaft, whereas in the four-stroke engine, the thermodynamic cycle completes in the two revolution of crankshaft. And the two-stroke engine are the weight to power ratio of two-stroke engine. It is high, so its cargo carrying capacity is more. And in the four-stroke engine, the weight to power ratio is low. It is having more weight, but still it cannot produce the power as more power as compared to the two-stroke engine. And the horsepower which is produced by the two-stroke engine, it is theoretically twice the two-stroke engine, but practically it's 1.5 to 1.8 times the four-stroke engine. And basically the volumetric efficiency of the two-stroke engine is less as compared to four-stroke engine. And in the two-stroke engine, for suction and discharge, there is no separate stroke. That's why its scavenging is poor. Whereas in the four-stroke engine, the scavenging is better. And in the two-stroke engine, basically the lube oil consumption is more. Four-stroke engine lube oil consumption is less. And the two-stroke engine are less complex as compared to four-stroke engine. And two-stroke engine requires less maintenance as compared to four-stroke engine. And also two-stroke engine it is a bidirectional engine, whereas four-stroke engine it's not a bidirectional engine. And these are the some. And camshaft to crankshaft ratio of the two-stroke engine is 1:1. For the four-stroke engine, that is camshaft to crankshaft ratio is 1:2.
What is camshaft?
Camshaft, it is a device which is used for controlling the wall operation, which is used for closing and opening the walls with the help of push rod, rocker, and arm assembly and wall spring.
Okay. How does the camshaft works totally?
So basically, camshaft is crankshaft is connected to the camshaft with the help of timing gear or the timing chain arrangement, and
Mm-hmm.
camshaft rotate as per the stroke. Sorry, camshaft rotate as per the power stroke, and crankshaft rotate as per the stroke. So when the crankshaft start rotating with that, so the camshaft rotate as per the power stroke. That's why we get camshaft to crankshaft ratio 1:2,
Mm-hmm.
and basically camshaft is driven by the crankshaft. So
Mm-hmm.
when the camshaft moves, uh, means it's bulky portion, when it moves in upward direction, then it pushes the push rod in upward direction, and
Mm-hmm.
push rod pushes the uh, rocker and arm assembly downward,
Mm-hmm.
and the due to which the wall spring gets compressed and wall opens.
Okay, what is
So this
tappet
is how.
clearance?
Tappet clearance is basically clearance between yoke and rocker and arm assembly, and
Mm-hmm.
basically this clearance is provided with this clearance is more for the expansion wall.
Exhaust side.
Sorry, yeah, exhaust side means expansion wall,
Yeah,
I think.
expansion valve. Yeah, exhaust side it will be more clearance. What happens if the clearance is less? Tappet clearance is less. What will happen?
Basically, if the tappet clearance is less, then wall will open sooner and close later. And if the wall will open sooner, then the fuel consumption will increase.
Mm-hmm.
And also more amount of the exhaust gases will remain inside the combustion chamber.
Mm-hmm.
And due to which the temperature of the exhaust gas will also increase and power output will also decrease.
Mm-hmm. Correct. And what is butt clearance?
But clearance is basically clearance between the connecting ends of the piston ring, and basically that clearance is given up to 0.075 sorry 0.077 mm to 0.1 mm,
It is
and
the clearance between the piston ring and the casing, right? Butt clearance.
uh, no, it is a clearance between the means if this is ring, then that clearance between this ring ends, that is a butt clearance.
Okay, okay. Mm-hmm. Okay, and then can you explain exhaust gas turbocharger?
Yes, when the combustion takes place inside the combustion chamber,
Mm-hmm.
the exhaust gas is produced, which is having the temperature up to the 380 to 450 degrees Celsius,
Mm-hmm.
and this high pressure and high temperature exhaust gas is supplied to the exhaust manifold, and from exhaust manifold, with the help of the nozzle, this high pressure fluid
Mm-hmm.
impart on the turbine of turbocharger,
Mm-hmm.
and basically with the help of nozzle, it speed up the uh, flow of the exhaust gas which is imparted on the
Mm-hmm.
uh, basically uh, turbocharger,
Mm-hmm.
the turbine of turbocharger.
Mm-hmm.
And when this gases comes out from the turbine of turbocharger, it is having the temperature up to 220 degrees Celsius.
Mm-hmm.
And basically when this turbine of turbocharger, when this impeller or rotor of the turbine of turbocharger start rotating, with that the rotors is start sorry with that shaft of the turbine start rotating, and this shaft of the turbine is connected to the compressor or blower shaft. So with that, compressor also start rotating, and when the compressor start rotating, it sucks the air from the engine room.
Centrifugal
And
blower, right? Compressor or blower? Centrifugal blower करके I wrote.
blower, yeah, centrifugal blower.
Blower. It's not a compressor.
Okay, blower. So this centrifugal blower sucks the air from the engine room and compress it.
Mm-hmm.
And when the air is get compressed, its pressure and temperature increases. So, and the temperature of the air which is supplied, that is increases up to the 160 degrees Celsius.
Mm-hmm.
And basically when the temperature increases, then the density decreases.
And you will
And
pressurize the air also in
yeah,
the centrifugal blower.
yes. I had already told that its pressure and the temperature of the air which is supplied will increase.
Okay, I heard only temperature will be increased, so I asked.
No, no, no. The pressure and the temperature of the
Pressure
air
rises
will
up to
increase.
2.2 bar.
Okay, 2.2 bar.
Yes.
Okay. Yeah, yeah.
Yeah.
Connecting faces of the piston.
Yeah.
Ring.
Yeah.
and the pressure of the air, the pressure of the compressed air is increases up to 2.2 bar, and the temperature of the air is increases up to the 60 bar. And we know that when the temperature increases, then the density decreases, and density is equal to mass by volume. So if the density, if the volume is constant, and if the density decreases, then mass also decreases. And we want maximum amount of mass of air. And if the temperature increases, we get minimum amount of mass of air. That's why we supply the this high pressure, high temperature compressed air from the filter to the air cooler, and inside the through the air cooler tube, the compressed air is supplied, and it is then air cooler tubes are surrounded by the seawater. So heat rejection, constant pressure heat rejection, I think heat rejection takes place, and the temperature of the air is maintained up to the 35 degrees Celsius, and sorry, 45 degrees Celsius.
40 to 45 degrees Celsius. Yes.
Yeah, 45 degrees Celsius, and this air is applied to the again inlet manifold. And the temperature of the seawater, which is surrounded by the evaporator, that is air cooler coil, that is also increased up to the 35 degrees Celsius.
Okay. And okay, can you explain what is cavitation?
Basically, cavitation, it is a process in which a bubble formation starts when the vapor pressure of liquid is more than the local pressure.
Okay, what are its effects?
Basically, due to the cavitation, the impeller damages, also noise level increases, noise level of pump increases. Also, there causes more fluctuation and vibration in the pump.
Okay.
Also, it causes the flow loss and life of pump decreases.
Actually, what I heard is cavitation is whenever the saturated pressure is decreases in the some point of the blade, then as saturation pressure decreases, no, then saturation temperature will also decrease. If the water reaches that saturation temperature, then the bubble formation will start. And whenever the bubble formation will breaks down, there will be means like the waves, means like whenever.
Okay, you want me to answer in brief. Also, if you'll ask me to answer in brief, then I'll answer. So when the flow is erratic, then it do not strike the blades of impeller at a desirable angle. That's why basically kinetic energy or the velocity of fluid increases. That's why the pressure decreases. And we know that at a low pressure, water can be easily converted into the vapor, because if the pressure decreases, boiling point also decreases. And due to decreasing the pressure, the bubble formation may start in the fluid, and this bubble strikes to the blades of the impeller, and it bursts. That's why it causes the pitting, or the small pieces of the impeller comes out, and over the time the impeller damage, and due to which it cannot able to, over the time it is not able to achieve the desirable pressure or vacuum pressure inside the pump. That's why flow loss also causes.
I think that if you answer whenever this question asked in the interview, if you answer in brief, it would be good. Okay.
I thought you just asked me for the definition. I think you asked only definition.
No, it's fine. And next question is, what is normalizing?
Annealing, normalizing. So normalizing is basically a heat treatment process in which the substance is heated up to its critical temperature and again cool it down. So basically this is done to refine the material internal structure.
Okay, you know the annealing. What is annealing?
Yeah, annealing, it is basically heat treatment process in which material is heated at a specific temperature and hold it at that temperature for a certain period of time and again cool it down. So this is done to increase the ductility of material.
Correct. And you know what are the types of welding?
Welding, arc, gas welding. Then in the shipping also there are different types of weldings are performed, like shield metallic arc welding, then tungsten metallic arc welding, flux arc welding, then submerged arc welding. These type of weldings are performed.
Okay. What are the types of drilling operation?
Oh, drilling operation. Sorry, I don't know.
What is drilling?
Drilling is making the hole.
Yeah.
I think.
Yeah, that is the thing. Wait 1 second. Types of drilling they will not ask, only types of welding they will ask, and they will ask they had asked the definition of drilling, means like what is the drilling. Okay, it is the process of making the holes into the workpiece. That is what we can tell.
Okay.
Sorry, it's not types of drilling, only types of welding it is there. Only drilling ka definition they have asked. I'm sorry. Okay. What is generator?
Basically, generator, it is a device which is used to convert the mechanical energy into the electrical energy.
Mm-hmm.
It works on the Faraday's law of electromagnetic induction.
Mm-hmm. What is flywheel?
Basically, flywheel, it is a device which is used to store the energy during the power stroke and release that energy during the non-power stroke. And basically, energy stored by the flywheel is directly proportional to the rotating speed of the flywheel.
Mm-hmm.
And basically, it is used to provide the continuous torque, or it is also used to reduce the imbalance, the rotational forces of the crankshaft.
Mm-hmm. What is a thermocouple? Its connection and its connection.
Thermocouple, sorry bro, I don't know even thermocouple. 1 minute, a thermocouple, is it used to find out the unknown resistance or?
No. Thermocouple, as far as I remember, it is used temperature measuring device only. It is.
Okay.
I also not able to recall it actually. This is asked in SIMS.
Glass screen SIMS thermocouple.
Hmm.
I had written it somewhere.
Total full question I will read. See, what is thermocouple and its connection? One tricky question: if there is a circuit connected with the bulb, if you connect a diode in series, then what will happen to the current? Will the current will flow or not? This is the total.
Sorry,
question.
sir.
This is means you just prepare it. Means I will just ask all the question. Today we will just list out all the question. How much you will know, we will get to know. Then whatever you will miss, no, you can go and recall it. Means this is the only way we have. Means like to prepare as it is August 1, no, your interview is. So we can prepare. Then what is priming?
Priming, it is a process of removing the air from the system, and priming it is done for only the rotodynamic pump. And in the priming, there are two types: manual priming and priming with the help of self-priming pump. So in the manual priming, from the priming port, we fill the water inside the pump, and whatever the air which is inside the pump, that is taken out by the air, and this air goes out from the air vent wall of the pump, and we supply the water inside the pump until the water don't come out from the air vent wall. And once when the water starts coming from the air vent wall, then we close the air vent wall and also the priming port, and then we start the pump. So this is the first method, and second method is the priming self-priming unit. Also in the self-priming unit, priming pump is used. So when the centrifugal pump starts rotating, with that the priming unit rotates, and it sucks all the air which is present inside the suction side of the pump. So this is also a vacuum pump, and this priming unit is used when we have to suck the water from down below. Then the priming unit is used, which is used in emergency fire pump.
Okay. And working of a thermostatic expansion valve, you know?
Yes, the thermostatic expansion valve basically acts like an orifice. So it is having suddenly increasing area, and
Wait.
Yes.
Wait.
am I audible now?
Yes. Tell me.
So at the thermostatic expansion valve, the adiabatic expansion takes place, and it is having suddenly increasing area.
Isenthalpic expansion, you can tell actually. In various books it is isenthalpic expansion only, and it follows the adiabatic law. So otherwise Joule-Thomson effect also it is fine, but it is isenthalpic expansion or Joule-Thomson expansion.
Okay. The isenthalpic expansion takes place at the thermostatic valve. So I think isenthalpic expansion The reversible isenthalpic expansion means I think
No,
adiabatic
it is not a
expansion.
reversible isenthalpic expansion, because it is
Okay.
dotted line we will join, no. So it is an
Okay.
irreversible process. If we ask which type of process in thermostatic expansion, it is irreversible process. Because of that, we will
Okay.
join it by
Irreversible.
a dotted line. If you see.
I just wanted to ask one thing. What is this, why we show it with the dotted line?
Yeah, because it is irreversible process, no. So we are showing it by dotted line.
Okay. Okay. Okay.
That is what I am telling. So you should not tell a reversible isenthalpic. It is an isenthalpic expansion process. It is not
Okay.
not reversible. It is irreversible.
If it is irreversible, then we show it with the dotted line.
Yes.
And basically, the isenthalpic expansion, right?
Yes. Yes.
Yeah, isenthalpic expansion takes place at the thermostatic wall, and it is having basically suddenly increasing area.
Hmm.
And when the high pressure liquid refrigerant comes into suddenly increasing area, then it's the temperature and the pressure decreases, because according to the gauge law, when the volume is constant and when pressure decreases, then temperature also decreases. That's why basically the temperature and the pressure of the liquid refrigerant which is supplied
Are
is
you sure
decreases.
about the loss and all? According to which law you told?
Gauge Lucius law, I
Gay-Lussac
think.
law.
Lucet. Gauge
Gay-Lussac law.
Lucet law.
Then you are you sure about it? Gay-Lussac law. That one only it is taking place.
Yeah, yeah, I'm sure.
Because it is an ideal gas law, no. If it is this is a saturated liquid refrigerant is entering into the thermostatic expansion valve. This is a liquid refrigerant. How can you apply the that law, ideal gas law?
Yeah, basically ideal gas law is applied when the fluid is ideal, right?
Yeah, this is a
Yeah, but
liquid
it's not an
refrigerant.
ideal fluid. Yeah, it's not an liquid refrigerant.
This is a liquid refrigerant, right? Then how can you
Yeah,
apply
yeah,
the
yeah.
ideal gas law?
No, we can't apply.
Then how can you tell that
Yeah.
it is following Gay-Lussac law?
So basically it
So
is
if you
not.
are not sure, no, don't go into that depth. Then these questions and all they will ask. When I have researched about it,
Okay,
no, they are telling that it directly it is not following the ideal gas law. But you are
okay,
assuming that it is following ideal gas law, then you are applying it, and it is an irreversible process. Another thing is correct.
okay, okay,
So it directly does not follow the ideal gas laws. So better you tell it is
okay.
follows the isenthalpic expansion where is
Expansion.
going to takes place, and high pressure
Okay,
high temperature liquid refrigerant is converted, it is flow through the orifice and it is converted to low pressure low temperature saturated liquid plus vapor refrigerant, and the composition will be 80% liquid 20% vapor. Katam.
20%.
Only this much you tell,
20.
it's fine.
Okay,
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 if you
okay, okay.
tell more, if you go into more depth, no, then the questions will
Mm-hmm.
be he will ask, means cross question and all. Only this much you
Okay,
tell, and he doesn't expect also us to know that to that extent. Okay,
okay.
what you will tell? Tell again.
The basically at the thermostatic expansion one, it acts like an orifice. So, uh, isenthalpic expansion takes isentropic expansion takes isenthalpic expansion takes place.
Isentropic will take place in compressor there.
Okay.
Isenthalpic.
Isenthalpic expansion takes place at the thermal expansion wall,
Hmm.
and it converts the low pressure, high pressure liquid refrigerant into the low pressure liquid and vapor mixture refrigerant,
Hmm.
and in which there are 20% of the vapor refrigerant and remaining 80% of the liquid refrigerant, and it basically controls the supply of the refrigerant to the evaporator by
Hmm.
the signal received from the centrifugal pump.
Hmm. Okay. Through the capillary tube, if you are telling that extent.
Okay.
Okay. Hmm.
Capillary.
Then can you explain VCRS system full?
Okay. In the VCRS system, it consists of the compressor, condenser, the dryer, the
Hmm.
thermal expansion wall,
Hmm.
and evaporator.
Hmm.
So the low pressure vapor refrigerant is supplied to the compressor, and in the compressor, isenthalpic expansion, yes,
Ah,
isenthalpic compression takes place at
isenthalpic.
the
Ah. Isentropic. Compressor there is isentropic. Thermostatic
Oh,
expansion valve it is isenthalpic.
isentropic na?
Yes.
Isentropic. And at the thermal expansion wall, that is isentropic.
Isenthalpic. Thermostatic expansion valve isenthalpic, and in
Okay,
compressor
okay.
isentropic.
Okay, 1 second. Isentropic. Isenthalpic expansion. So in the compressor, in the compressor, isentropic expansion takes place,
Compression takes
and
place.
isentropic compression takes place,
Hmm.
and by reducing the volume, the pressure of the vapor refrigerant pressure and the temperature of the vapor refrigerant is increased, and at the outlet of the compressor, we get high pressure and high temperature vapor refrigerant, and this high
Superheated
pressure
vapor
high temperature.
refrigerant.
Okay, superheated vapor refrigerant is supplied to the condenser, and in the condenser, constant pressure heat rejection takes place. In the condenser tubes, the compressed air, the superheated refrigerant is supplied. So heat is rejected by the superheated refrigerant. That's why temperature decreases, and at the outlet of the condenser, we get high pressure uh, liquid vapor mixture refrigerant, and that is supplied to the uh, dryer. So a
Not
dryer
liquid vapor,
consists
means
of.
in condensation the high temperature superheated vapor enters into the condenser. There will be a sea water there, the heat loss will be taking place. Then high pressure high temperature superheated vapor is converted to high pressure slightly low temperature saturated liquid refrigerant. Then this saturated liquid refrigerant enters
Okay, okay.
into the आगे you tell आगे का.
Okay, then it is supplied to the silica. It's supplied to the dryer, which is having the silica gel. So it absorbs all the moist present in the refrigerant and supply the high pressure liquid refrigerant to the thermostatic valve.
Mhm.
And in the thermostatic valve, isenthalpic expansion takes place,
Mhm.
in which the low pressure liquid refrigerant is converted. High pressure liquid refrigerant is converted into the low pressure liquid vapor mixture refrigerant, which is having the 80% of uh, liquid refrigerant and remaining 20% of the vapor refrigerant. And then this liquid vapor mixture refrigerant is and basically thermal expansion will control the supply of the refrigerant to the evaporator according to the signal received from the sensible bulb
Sensing
and
bulb.
sensing bulb.
Hmm.
Then this low pressure liquid vapor mixture refrigerant is supplied to the evaporator coil, and evaporator takes the hot air which is coming out from the meat room, and this evaporator coils are
Refrigerated
surrounded by.
space you tell, not meat room. Refrigerated space.
I didn't get what you said. This refrigerator.
Refrigerated space you tell. Don't tell the meat room. Means it can be anything, right? Refrigerated space you tell. It
Okay,
can be domestic
refrigerator.
refrigerator, it can be meat room, it can be vegetable room, and different room has a
Okay,
different evaporator temperature too. So
okay,
you tell a refrigerated space. That is the word, proper word.
okay, refrigerated space.
Hmm.
Okay, that comes out from the refrigerator space, and hot air which is coming out from the refrigerator space it is supplied to the the evaporator, and in the evaporator, constant pressure heat addition takes place.
Mm-hmm.
So heat is transferred from the surrounded hot air to the liquid refrigerant inside the tube,
Mm-hmm.
and due to which at the outlet of the compressor,
Mm-hmm.
at the outlet of the evaporator, we get low pressure vapor refrigerant, and this vapor refrigerant passes to the sensible bulb,
Sensing bulb.
sensing bulb, and basically if more super and basically 5 to 7 degree of the superheat is maintained inside the evaporator, and if the refrigerant which is coming out from the evaporator, if it is superheated refrigerant, then it sends the signal to the sensing bulb, and sensing bulb sends the signal to the thermostatic valve, and the thermostatic valve supply the more amount of the liquid refrigerant. And if more supercooled refrigerant is coming out, then sensible bulb sends the signal to the thermostatic valve, and the less amount of the liquid refrigerant is supplied to the evaporator. And the vapor refrigerant, low pressure vapor refrigerant which is coming out, that is supplied again to the compressor outlet, inlet, sorry.
Okay, and you missed one thing, that in sensing bulb, no, it will control the thermostatic expansion valve with the help of capillary tube. Okay.
1 minute, 1 minute. Sensing bulb
Controls the thermostatic expansion valve with the help of capillary tube.
capillary tube. Okay.
And then next question is two types of metal hardening process, you know.
No, sorry. Metal hardening.
Two types of metal hardening process and its advantages. Okay, this question you noted down. Tomorrow we will find the answer. Means this is like homework. Okay.
Okay.
How thermometer works?
Basically, we dip the thermometer into the solution, and
First you tell that whenever this question asks, no, first you to mention that thermometer works on the law of an zeroth law of thermodynamics. Whenever the whenever you put the thermometer into the high temperature body, so that in thermometer there will be a mercury. So and there is a sensing bulb will be there in the end. So that senses the temperature and it will increase the temperature of the mercury. So in turn, mercury, the volume of the mercury, the height will rises. To the
mercury will rise.
Mercury will be rise the corresponding to the temperature which it will be the sensor. So this is how it will works. Means it basically works on the zeroth law of thermodynamics. What is zeroth law of thermodynamics? When two bodies are thermal equilibrium with the third body, then in turn the two bodies are thermodynamically equilibrium with each other. What is the first body here? First body is the bulb, means like outer covering which will be there, no, means sensing bulb, that is the first body. Second body is the mercury. So the first body, then third body you can take it as an hour body, means like the body which it is measuring. Okay, so when the sensing bulb and the mercury are in thermodynamical equilibrium with each other, then the height of the mercury which it will rise, no, that and the our body, the body which it is measuring, that also will be thermodynamically equilibrium with each other. So like this, if you explain, no, then it will be the proper answer, I guess. Means like he is expecting that only, means which law it is working, and explain how this law is applicable with the thermometer. So I guess that is the intention why he is asking this question. Understood, no?
Okay, so I understand.
Okay. Then what is a stroke volume?
Stroke volume. That is volume between the top dead center to the bottom dead center. Or it's a swept volume, that is pi by 4 d square and real.
Yes, correct. Proper. And next. What is lubrication and why need this lubrication, and where in 4-stroke engine we will use the lubrication?
Basically, lubrication it is used to reduce the wear and tear, also to reduce the corrosion, also to for the heat dissipation we use the lubrication. And basically, may I tell how the lubrication is done in the 2-stroke? That is what I supposed to tell.
No, means like how lubrication works, that not that is not you want to tell. He is asking where all we will lubricate in 4-stroke engine.
Okay, in the 4-stroke engine we supply the lube oil to the main bearing, and from the main bearing the fuel oil, the lube oil is supplied to the basically crank pin bearing, and from the crank pin bearing the lube oil is supplied through the connecting rod to the piston to dissipate the heat of piston. Then the loop oil drops back to the
Okay.
and
And another thing,
voltage regulator,
yeah,
which is used to.
what is AVR?
I just know the full form, but I don't know exactly what is used
That is
to.
only he asked. Means what is AVR? Means full form you tell, and what is its working? Okay.
It is used to control the voltage
Yeah.
according to resistance.
Yeah, that much only enough, I guess. What do you mean by RMS value?
RMS value, it is a root mean square value.
Huh. Yeah.
That's what only I know because I have to study this electrical question.
Hmm.
There are more questions.
Hmm.
I know, but I haven't revised it. That's why I don't know that.
Hmm. Why voltage is stepped up for a transmission?
To reduce the power losses while transmitting from one point to another.
Hmm. Okay.
Is it true?
Yeah, I also guess that is only the answer. I also don't know.
Okay.
And what is the how four-stroke petrol engine works?
Four-stroke petrol engine.
Yes. Means you tell the it is from carburetor the this will come means mixture of the air and fuel will enters into the from the carburetor it is enter into the casing. That one means everything full process how the four-stroke engine is there, no, that one you explain.
No, I have to just ask that if they will ask that the process for the petrol, four-stroke petrol diesel engine and four-stroke diesel engine, then only in the diesel engine we don't need to say the
Carburetor you should not tell. If it is a
and
four-stroke
in
diesel
the
engine, if you ask no, then you should not tell the carburetor and all. Means there will be a fuel injector will be there, no? Fuel injector will supply, only air will be sucked inside. Then whenever the stroke will go up, no, in compression stroke, then there will be a fuel with the help of fuel injector, fuel will be sparkled. Means like fuel will be sparkled, then there will be combustion takes place.
Okay, but there will be but there will be difference because I think in the compression, sorry, in the uh, petrol engine, basically air fuel mixture is supplied, right?
Yeah.
Then in the suction stroke of the petrol four-stroke petrol engine, then will it suck the air from the suction head then?
Air and petrol both mixture will be sucked inside from the carburetor. In carburetor mixes
During the suction.
with the proper proportion it will mixes the air and fuel. Then it will sent through the inlet valve and enters into the IC engine in the casing. IC engine engine it will enters. Then the inlet valve will close. Then there will be a compression stroke will be there. Where after compression there will be a spark ignition. Spark plug will ignite the air fuel mixture. Then after ignition there will be a power stroke with high force it will come down. Okay, after it will comes down now, then as it goes up the exhaust valve will open. Then then it is called as exhaust stroke. Then air the combustion gases whichever will be there no, inside the engine cylinder,
Yes.
it will be sent
Uh,
out.
uh, okay, I just have to ask that if you'll ask me for the correct me if I'm wrong, in the four-stroke in the diesel engine during the suction, then the piston moves from the top dead center to the bottom dead center. That's why the volume will increase and the pressure will decrease. That's why and then air fuel mixture will be injected into the
Only air will be injected inside.
in the petrol and diesel, sorry, in the petrol four-stroke engine.
In the petrol four-stroke engine, air fuel mixture will come. Yeah,
Yeah,
it is
I'm
proper.
asking that.
Yeah, this is proper.
And
You told
and
diesel when
during
you are asking, so I am confused.
oh sorry. And I just have to ask another thing that during the compression, at the end of compression, before the piston reaches to the top dead center, the air fuel mixture is injected, right, in four-stroke engine, right? But in the petrol engine, will it inject the fuel? Means the fuel injector will not be there.
No, it will not be there.
Okay.
Instead of the fuel injector, there will be a spark plug. यो गैस को ऑन करने के लिए एक लाइटर रहता है ना,
हाँ.
उसी तरह एक स्पार्क प्लग रहता है इस इंजन में. इट विल जस्ट इग्नाइट इट.
बैटरी इग्निटर सिस्टम का एक पार्ट रहता है.
हाँ, स्पार्क प्लग रहता है. स्पार्क इग्नाइट करता है. इग्नाइट करने के वजह से फ्यूल और एयर मिक्सचर को कंबशन होगा. देन आफ्टर कंबशन इट विल कम डाउन, पिस्टन विल कम डाउन.
ओके. और एक पूछना था कि इन द डीजल इंजन correct me. In the diesel engine during the suction stroke, the piston, the inlet valve remains, exhaust valve remains closed, inlet valve opens,
Mm-hmm.
and piston moves from the top dead center to the bottom dead center.
Mm-hmm.
Then the volume inside the cylinder increases. That's why the pressure decreases and the air is gets sucked into the
Mm-hmm.
combustion chamber.
Mm-hmm.
And during the
And
compression
valve
stroke,
you should
the
not mention. You should mention port in the inlet port, exhaust port, like that you should mention.
okay,
It is not the valve. Okay.
okay. Inlet valve in the compression stroke, the inlet and exhaust port remains closed, and the piston moves from the bottom dead center to top
Inlet
dead
port
center.
and
So,
exhaust port will be closed. Again, you
okay,
told valve.
inlet and
So I am.
yes, inlet and exhaust port will be closed, and when the piston will move from the bottom dead center to top dead center.
Mm-hmm.
By reducing the volume, the pressure of the air will increase, and it will
Mm-hmm.
increase up to the specific ignition temperature of the fuel.
Mm-hmm.
And before the piston reaches to the top dead center,
Mm-hmm.
the fuel will be injected into the combustion chamber.
Mm-hmm.
And when this atomized fuel come in contact with the hot gases,
Mm-hmm.
so whatever the energy which is stored in the fuel in the form of chemical bond, it is
Mm-hmm.
converted into the heat energy,
Mm-hmm.
and this heat energy will push the piston down. In
Mm-hmm.
the power stroke, the piston will be pushed downward,
Mm-hmm.
and in the expansion stroke,
Mm-hmm.
the inlet and exhaust port remains closed. Sorry, in the exhaust stroke, inlet port remains closed and exhaust port remains open,
Mm-hmm.
and the piston moves from the bottom dead center to the top dead center, and whatever the scavenger which is produced, that is
Mm-hmm.
removed from the
Mm-hmm.
combustion chamber.
Mm-hmm. Correct.
Is it right?
Yes. Yes.
Okay, I'll tell about the petrol engine.
Mm-hmm.
Okay, so for the petrol engine, during during the suction stroke, the piston moves from the top dead center to the bottom dead center. So volume increases when the pressure decreases.
Mm-hmm.
That's why air fuel mixture uh, sucked into the combustion chamber.
Mm-hmm.
And during the compression stroke, the piston moves from the bottom dead center to the top dead center, and
Mm-hmm.
inlet and exhaust port remains closed.
Mm-hmm.
And as the piston before the piston reaches to the top dead center,
Mm-hmm.
the the spark is produced.
Spark is ignited.
Okay, spark is ignited, and due to which fuel start burning,
Mm-hmm.
and more amount of the hot gases, means whatever the energy is stored in the fuel is converted into heat energy,
Mm-hmm.
and that pushes the piston downward.
Mm-hmm.
And during the exhaust stroke, whatever the inlet port remains closed, exhaust port remains open, and
Mm-hmm.
the whatever the exhaust gases which is present inside the combustion chamber, that is removed.
Yes. Proper. Correct. It is.
Thank you.
Okay, this much if you tell, it's fine. And sometime in a two-stroke diesel engine, it is called as the intake inlet port will be there. No, the scavenge port they will tell. Scavenge air will enters inside. Like that.
Okay, scavenger will.
Enters inside. Means like where inlet port what function it will does, no, entering inside. The same thing will be done by scavenge port. Means scavenging air will enters inside the fresh air. Then in during exhaust port only it will goes everything. But scavenge air enters through the scavenge port. That much only difference
Okay.
in two stroke. Okay. Rest all is function is same. Rest all is same.
Yeah.
Okay. Then flywheel you told, no? Wait. What are the types of boiler? Boiler accessories and mounting. Boiler mounting तो तुम बोल दिया. Boiler accessories बोलो.
Okay. Boiler accessories are feed check valve.
Hmm.
Sorry. Feed pump.
Hmm.
Then air preheater,
हाँ.
steam superheater,
Hmm.
and economizer. These
Exhaust
are
gas economizer.
the exhaust gas economizer.
उतना ही. Okay. What is the power developed by the engine and its formula? Brake power and indicated power. What is the power developed by the engine?
The power developed by the engine, that is PM into LAN by 60 for the two-stroke engine, and for four-stroke engine it is PM into LAN by 60,
Hmm.
LAN by 120, sorry.
Hmm. Correct.
And PM it is calculated by the area of power card divided by the length of power card,
Hmm.
and the area of power card it is also calculated by the planometer.
Hmm.
And indicated power it is equal to, yeah, I think indicated power is
Brake
same.
power is 2 pi
PM,
nt 2 pi nt divided by 60, and indicated power is PLAN divided by 120 as you told.
yeah, indicated power is PM into LN by 60.
हाँ वही
Am I?
मुझे भी कंफ्यूज हो गया वो. हाँ.
नहीं, it is true, but I think power output is what? The power produced is what? Means I don't know.
वो power
PM into pi by 4 d square into, no, pi by 4 d square into L. No, that is also not good.
PM into L into pi by 4 into pi by 4 into d square वो है ना, and number of
No.
screw.
Brake power it is uh, that is torque into RPM by 60.
या 2 pi nt divided by 60. 2 pi n मतलब ओमेगा. हाँ टॉर्क, ओमेगा इज टॉर्क है. टॉर्क into
Torque
ओमेगा
into
divided by हाँ
that is
ओमेगा.
calculated by the dynamometer, or especially field type dynamometer is used to calculate that.
Yes.
What I had written, I don't know.
Indicated power plan divided by वो वही है.
I had written one thing that power is equal to PM into pi by 4 d square into L
हाँ
into number of revolutions.
वही हुआ ना प्लान PLAN.
And the power produced, sorry, the power is pi by 4 d square into L N by 60. Yeah, that's right. PM into L AN by 60.
हाँ
Yeah, indicated power is PM into L AN by 60,
हाँ.
and power produced is PM into pi by 4 d square into L
हम्म
into N by 60 for two stroke.
वही. How does engine starts?
For the marine engine,
Hmm.
or basically for starting the marine engine, the lubrication system is started first. So for the two-stroke engine, for the main engine, lubrication system started 1 hour before starting the main engine, and auxiliary before or lubrication started for the auxiliary engine 15 minutes before starting the auxiliary engine, and then checking whether all the required parameters are in working condition or not. Then after the indicated clock is open and remove all the exhaust air which is present, then rotating the crankshaft so that lube oil will reach till all the parts of the lube oil will reach till all the parts, and then the exhaust gas temperature, jet cooling water temperature is checked. So for the for the main diesel engine, the jet cooling water temperature is maintained up to the 60 degrees Celsius, and for auxiliary engine it is maintained up to the 45 degrees Celsius. And then after checking the jet cooling water temperature, the gear interlock is checked, and it ensures that it is from the signal we get a signal that disengage the signal. So once we get disengage signal, then we check, then we run the engine on no load condition. Means, without any load, the engine is run for the 5 minutes. Engine is started for the 5 minutes. Then we check whether the exhaust valve. Then we avoid the opening of the exhaust avoid the excess opening of the exhaust valve, and then examine the engine. And then it's better to start the engine from its local location instead of the remote location. So this is how the engine is started.
Okay. And then what are the parts of lathe machine?
Lathe machine are tailstock, tailstock, headstock, then carriage, then tool post, lead screw, then carriage wheel. What to say? That is also one part.
Yeah.
Then jaw chuck key.
Wait a second. I will tell you. Speed and headstock, tailstock, chuck, चक की, टूल पोस्ट, कंपाउंड हैंड व्हील, क्रॉस साइड हैंड व्हील, कैरेज हैंड व्हील एंड पावर फीड लीवर एंड देर इज वेस मतलब वो रहता है ना, मतलब जो भी कट होता है वो जब कलेक्ट करता है
कलेक्ट
हाँ वेस मतलब वो ये कंपाउंड, ये जो कैरेज है ना, कैरेज जो मूव करते हैं ना वो वेस के ऊपर मूव करते हैं, उसे वेस बोलते हैं. और देर इज अ ड्रिल चक मतलब टू होल्ड द वर्क पीस, द ड्रिल चक इज यूज मीन्स इट इज टेल स्टॉक में चक रहता है ना.
डेड सेंटर समथिंग दे कॉल्ड इट.
नहीं, टेल स्टॉक में वो जो रहता है ना उसे ड्रिल चक कहते हैं. और चक की भी रहता है. और कैरेज हैंड व्हील वो भी रहता है. कैरेज हैंड व्हील मतलब क्रॉस साइड व्हील जो रहता है ना वो लॉन्गिट्यूडिनल मोशन प्रोवाइड करता है. और कैरेज हैंड व्हील जो हम रोटेट करते हैं ना अक्रॉस रोटेशन में, अक्रॉस मूव करने के लिए ये कैरेज हैंड व्हील यूज करता है.
ओके वेट कैरेज हैंड व्हील. कैरेज व्हील
मैं तुझे फोटो ही भेज दूंगा, मतलब ये फोटो मतलब ये पीडीएफ में बनाया हूँ, लेथ के ऊपर ही मैं बनाया हूँ स्पेसिफिकली. वो तो मैं भेज दूंगा, ये हेल्प होता है. और उसमें मतलब हेड स्टॉक में 2 गियर बॉक्स रहता है, वो क्यों रहता है?
I don't know. I haven't searched about it. I just know the parts and types
ये
of.
एक इम्पोर्टेंट क्वेश्चन है. देखो गियर बॉक्स जो रहता है ना, 1 गियर बॉक्स इज कनेक्टेड टू द चक टू कंट्रोल द रोटेशनल स्पीड. ओके. और इन द लेथ मशीन
Gearbox basically we use that to increase the speed ना.
हाँ, 1 गियर बॉक्स सिर्फ रोटेशन स्पीड मतलब कंट्रोल करने के लिए यूज करता है. मतलब इट विल बी इन द फॉर्म ऑफ 24, 36, 12, मतलब वो इस ऑर्डर में वो स्पीड रेवोल्यूशन होता है. मतलब इसमें मतलब 3 रहता है, 3 स्पीड. मतलब हमारा कार में जैसे 5 रहता है ना, 4 रहता है. इसको रिवर्स को मिला के 4 नहीं 5 रहता है, 5 और रिवर्स को मिला के 6 रहता है. इसमें 3 रेवोल्यूशन होते हैं. मतलब एक 24, 36 और 12, मतलब ये स्पीड रेंज रहता है. इसके ऊपर एक गियर बॉक्स
20, 24 और
हाँ 12, 24, 36 ऐसा रहता है. ठीक है. और सेकेंड गियर बॉक्स जो रहता है ना वो फीड कंट्रोल करने के लिए होता है. फीड मतलब वो उसको मतलब कितने आरपीएम, कितने एमएम पर रेवोल्यूशन में हमें वर्कपीस को आगे बढ़ाना है, उसको कंट्रोल करने के लिए हम वो सेकेंड गियर बॉक्स रहता है. और ये क्वेश्चन ये पूछ सकता है, ये क्या ये दोनों गियर बॉक्स इंडिपेंडेंट रहता है या डिपेंडेंट रहता है? वो दोनों गियर बॉक्स इंडिपेंडेंट रहता है.
ओके
ठीक है. एक गियर बॉक्स से दूसरे गियर बॉक्स में कोई कनेक्शन नहीं रहता. सो यही एक क्वेश्चन हो सकता है. और लीड स्क्रू में एक्मे थ्रेड होता है, एक्मे थ्रेड.
ओके
लीड स्क्रू में एक्मे थ्रेड होता है.
आपने वो लिखा है क्या सबको?
हाँ ये सब मतलब लिखा हूँ मैं, तुम्हें पीडीएफ ही भेज दूंगा. मैं इतना जितना है ना इतना पढ़ लिया तो इंटरव्यू के लिए काफ़ी है. ठीक है. और लेथ मशीन इज नॉट अ मशीन टूल. व्हाई? लेथ मशीन इज नॉट अ मशीन, इट इज़ अ मशीन टूल. व्हाई? मतलब उसे मशीन नहीं कह सकते हम, मशीन टूल कहते हैं. उसके लिए 5 रीज़न है. एक रीज़न इट रन्स ऑन पावर. दूसरा रीज़न इट इज़ रीजनेबली वैल्यूड, मतलब उसके लिए वैल्यू है लेथ मशीन के लिए. तीसरा इट हैज़ अ कटिंग एज. चौथा इट हैज़ अ कटिंग टूल. एंड 5वां इट इज़ नॉन पोर्टेबल, वो पोर्टेबल नहीं है. सो ये 5 रीज़न है. ये सारा मैं इसमें लिखा हूँ, मैं तुम्हें भेज दूँगा बाद में.
इसमें पूछा क्या है सिम्स केस में?
सिम्स में मतलब हाँ ये पार्ट्स ऑफ द लेथ मशीन ये पूछा है, पर इंटरव्यू के लिए मैं इंटरव्यू में ये क्वेश्चन पूछा है, मतलब क्या ये 2 गियर बॉक्स जो रहता है ना वो इंडिपेंडेंट है या डिपेंडेंट है? इट इज इंडिपेंडेंट. सो ये दोनों तुम याद रखो.
2 गियर बॉक्स यूज किए जाते हैं ना? हाँ
2 गियर बॉक्स यूज किया जाता है. वो दोनों गियर बॉक्स हेड स्टॉक में लोकेटेड रहता है. एक गियर बॉक्स स्पीड कंट्रोल, दूसरा गियर बॉक्स फीड कंट्रोल. हाँ ये दोनों इंडिपेंडेंट है. दोनों इंडिपेंडेंट है ना, ये इम्पोर्टेंट है, ये पूछा गया है इंटरव्यू में.
ओके इंडिपेंडेंट है.
ठीक है. और लीड स्क्रू अगर ये नहीं पूछेंगे, अगर पूछे तो एक्मे थ्रेड होता है लीड स्क्रू.
Lead screw I think used to, I have read somewhere that lead screw it is used to transmit the power from.
नहीं लीड स्क्रू जो है ना ये कैरेज मूव करने के लिए यूज करते हैं. इसमें मतलब 2 रहता है, एक लीड स्क्रू और एक लीड रॉड. रहता है, इसके बारे में पूरा मैं बोल दूंगा अगर चाहे तो। लीड स्क्रू जो रहता है ना, वो लीड स्क्रू सिर्फ ओनली कट द स्क्रू, मतलब कटिंग के लिए यूज़ करते हैं। लीड रॉड अदर देन स्क्रू एंड थ्रेड। हाँ, मतलब ये लीड स्क्रू जो रहता है ना, वो स्क्रू कट करने के लिए या थ्रेड कटिंग के लिए यूज़ करते हैं। बाकी सब के लिए हम लीड रॉड यूज़ करते हैं, मतलब कैरेज मूव करने के लिए। सो ये है मतलब इसका फंक्शन।
यार मुझे इतना डिटेल पता ही नहीं था।
इतना डिटेल चाहिए भी नहीं, तुम पूछा इसलिए मैं बोल रहा हूँ।
हाँ हाँ
इसमें जो चाहिए ना, दो ही चीज़ है, मतलब
हाँ,
दो गियर यूज़ करता है और दोनों गियर
वो
इंडिपेंडेंट रहता
इंडिपेंडेंटली मूव
है।
करते हैं।
हाँ, दोनों
और
गियर का
एक
फंक्शन क्या है, एक गियर स्पीड कंट्रोल करते हैं, दूसरा
स्पीड
गियर
इंक्रीज और दूसरा
फीड कंट्रोल
स्पीड
करते हैं।
कंट्रोल।
इतना जान लो बस है। और अगर ये पूछने का चांसेस कम है, लेथ इज़ नॉट अ मशीन, इट इज़ अ मशीन टूल, इसके लिए 5 रीज़न है, वो बाद में भेज दूंगा चाहिए तो।
ओके सर।
इतना ही बस है, मतलब ज़्यादा नहीं, ज़्यादा रिक्वायरमेंट नहीं है।
हाँ हाँ
और वर्किंग ऑफ कैमशाफ्ट बोल दिया ना। व्हाट आर द वेरियस
हाँ
पार्ट्स ऑफ आईसी इंजन, वो बोल दो।
हाँ वो पता है। वो बोल दो क्या?
हाँ बोलो बोलो, ये पूछा गया है।
The parts of the IC engine are camshaft, push rod, then rocker and arm assembly,
हम्म
then ball spring,
हम्म
uh, suction valve, discharge valve, fuel valve,
हम्म
then indicator clock, the
हम्म
cylinder head,
हम्म
then cylinder, piston,
हम्म
uh, Gudgeon pin or piston pin, or
हम्म
it is also called as wrist pin,
हम्म
then connecting rod,
हम्म
crank pin, crankshaft,
हम्म
uh, main bearing,
हम्म
then casing,
हम्म
then crankcase relief door,
हम्म
then the jet cooling water liner.
हम्म
These are the some parts of
ऐसे हैं। हाँ, वाई डू वी नीड ट्रांसफार्मर, ये पूछा है देख।
transformer. It is used to step up and that is used to transfer the current from the transfer the power from the one circuit to the another circuit either by
हम्म
increasing or decreasing the voltage,
हम्म
and it works on the Faraday's law of mutual inductance.
और
मुझे उसका वर्किंग भी बताना क्या पूरा?
नहीं नहीं, इतना काफ़ी है बस।
Okay.
हाँ, डिफरेंस बिटवीन सेंट्रीफ्यूगल पंप एंड पॉजिटिव डिस्प्लेसमेंट पंप।
Basically, in the case of centrifugal pump, the flow is affected by the head,
हम्म
uh, and in the case of positive displacement pump, the flow is not affected by the head. And in the positive the centrifugal pump works on the rotor-dynamic principle. Positive displacement pump work on the positive displacement principle. And in the centrifugal pump, the flow rate is affected by the flow rate decreases with increasing the viscosity. And in the case of positive displacement pump, the flow rate decreases with increasing the internal clearance. And in the positive in the centrifugal pump, basically efficiency is affected by the uh, pressure, but in the case of the positive displacement pump, efficiency remains constant with increasing the pressure. And in the in the centrifugal pump, load increases with increasing the flow. In the positive displacement pump, the load increases with increasing the pressure. And in the positive displacement pump, it is used when we require more flow at low head, or at a low pressure. Whereas the positive displacement pump is used when we require less flow at high pressure or at high head. And in the positive displacement pump, basically we require the priming. In the positive displacement pump, we do not require the priming. And in the centrifugal pump, we do not require relief valve. And in the in the positive displacement pump, we require the relief valve. These are the some differences between.
हाँ, और 13% ऑफ 199 कितना होता है?
कितना 13% ऑफ
199? नो, ये तुम ये यूज़ नहीं कर सकते, वैसे तुम माइंड कैलकुलेशन में बोलना चाहिए। ये मुझे मालूम है, ये जो भी सम देता है ना, तुम्हें कैलकुलेटर या पेन और पेपर यूज़ नहीं करना।
26.
करेक्ट। और 199 को 2 कर दो बस 13 इंटू 2 26 हो गया.
राइट.
और 5/3 of 36
5 बाय
5/3 मल्टीप्लाइड बाय 36 कितना होता है?
60.
हाँ वही है.
ये भी पूछ लिया क्या?
ये पूछा इसलिए पूछ रहा हूँ ना मैं.
भाई
Why do we need fresh water? ये कैसे सवाल?
Basically, fresh water is used for it is required for drinking. Also, the fresh water it is used in the jet cooling water liners because the we cannot use the sea water because it is corrosive. So that's why we in the jet cooling water system also we use the fresh water. And
Why fresh
it
water?
is
How
used
fresh
for
water
drink.
is generated in ship?
Basically, fresh water it is generated in the freshwater generator,
Mhm.
and the freshwater generator, the centrifugal pump is used to supply the fluid from the sea chest to the condenser, and basically in the condenser of the freshwater generator, at the inlet of the condenser of freshwater generator, the temperature of the seawater it is up to 28 to 31 degrees Celsius, and in the condenser basically heating media is used as a vapor. So heat transfer takes place from the hot vapor to the seawater, and the temperature of the seawater is increased up to the 40 to 42 degrees Celsius. And this and the outlet of the condenser is fitted to the evaporator, and basically evaporator it is in the evaporator the heating media the titanium what is titanium this titanium type of heat exchanger is used in the evaporator, and through this evaporator coil that seawater is supplied and it is surrounded by the uh, jet cooling water liner, sorry, cooling jet water. So in the evaporator, the heating media is jet cooling water. So with the help of jet cooling water, the temperature of the seawater it is increased up to 45 to 48 degrees Celsius, and by decreasing the pressure, the vacuum pressure is maintained inside the evaporator up to uh, 85 to 95%, and by decreasing the pressure, uh, the seawater is converted into by decreasing the pressure, uh, the seawater is boiled at a temperature up to 40 to 45 degrees Celsius, and it's converted into the vapor, and then this vapor is again condensed in the um condenser flask, something like that. I forgot. Condenser chamber, and at the outlet of the condenser chamber, thermometer is connected, which measures the amount of salt in the water, and if there is more amount of salt, then with the help of seaway wall bypass, the this water is again supplied to the evaporator, and if the water is drinkable, then it is supplied to the uh, main freshwater tank. So this is how
Okay.
pressure is generated.
Okay. Difference between centrifugal pump and reciprocating pump.
Centrifugal pump and
Reciprocating pump.
basically the difference will be same which I told for the positive displacement pump.
नहीं सेम
There
नहीं
will be
होता.
not difference.
क्योंकि पॉजिटिव डिस्प्लेसमेंट पंप अगर बोलूँगा तो तुम्हें गियर और स्क्रू पंप याद आना चाहिए. सेंट्रीफ्यूगल पंप इज वर्क्स ऑन ए रिवर्स्ड पिस्टन मूवमेंट. देखो पॉजिटिव डिस्प्लेसमेंट प्रिंसिपल. व्हाट इज पॉजिटिव डिस्प्लेसमेंट प्रिंसिपल?
Positive displacement principle is that I also don't know positive displacement.
See, despite of varying discharge pressure, the flow will be at the constant rate.
The flow is constant.
Flow is constant.
One question was there why the flow is it is called as positive displacement.
हाँ इसलिए
So
पूछा.
in that the reason is that during the at the discharge side of the centrifugal pump there is slight clearance between the impeller and the
Centrifugal
discharge
pump.
side.
सेंट्रीफ्यूगल
Yeah.
पंप रोटोडायनेमिक प्रिंसिपल में वर्क करता है ना. पॉजिटिव
Wait,
डिस्प्लेसमेंट.
I'm just saying. Let me complete.
Okay.
So in the case of centrifugal pump, there is slight clearance between the discharge side and the impeller. So during the pumping out, some amount of the liquid come back to the impeller. That's why its discharge is not constant. In the case of positive displacement pump, during the pumping out, water do not come back to the casing. That's why its discharge is constant. That's why it is called as positive displacement.
हाँ क्या मतलब मुझे लगा मतलब सेंट्रीफ्यूगल पंप में डिस्चार्ज क्यों कांस्टेंट नहीं रहता बोले तो वोल्टेज और करंट फ्लक्चुएशन रहता है मतलब हमेशा इट विल नॉट बी ऑलवेज कांस्टेंट
ये
वोल्टेज
मैंने
एंड
ना
करंट।
ये मैंने कहाँ से पढ़ा था बताया क्या, यूट्यूब पे मैंने दो चार वीडियोस देखे थे इसके, तो उसमें यही बताया गया था, तो यही मैंने
मतलब सेंट्रीफ्यूगल पंप में वाटर जब पंप करते हैं थोड़ा अमाउंट ऑफ वाटर वापस आता है क्या केसिंग में?
some amount of water come back to the casing during pumping out.
हाँ
And
हाँ
positive displacement तो ऐसा हो ही नहीं पाता, क्योंकि वो कंबशन चेम्बर में जब पिस्टन आगे जाता है तो पूरा ही फ्लूइड फ्लूइड बाहर जाता है ना,
हाँ
तो
हाँ
वाटर
हाँ
बैक कैसे आएगा?
ओके ओके वैसा है
तो
क्या?
फ्लो रेट कांस्टेंट रहेगा. It operate at a specific flow rate and at a specific discharge pressure.
आई थिंक ओबराय सर यही आंसर एक्सपेक्ट कर रहे थे मतलब एस्पिरेंट में बहुत
हाँ.
लोगों को मतलब रिजेक्ट भी किया था वो सारे लोग मतलब या उसको सेटिस्फैक्शन ही नहीं मिल रहा था उस आंसर से। मैं शायद यही
हाँ.
आंसर एक्सपेक्ट कर रहे थे शायद। देखेंगे नेक्स्ट क्वेश्चन। व्हाट इज टेंसाइल स्ट्रेंथ?
Tensile strength. Basically, tensile strength is the maximum stress a material can bear before the fracture, uh, during the stretching or during the stretching.
करेक्ट
That is a tensile strength.
ये और व्हाट इज पिस्टन रिंग्स एंड गजन पिंस?
Basically, piston ring, it is mounted on the piston, and Gudgeon pin, it is also called as wrist pin or the piston pin, that is used to connect the piston with connecting rod.
ठीक है व्हाट आर द फंक्शन ऑफ पिस्टन रिंग्स?
Basically, piston ring, it prevent the scavenge air to leak from the combustion chamber. Also, it is used for the heat dissipation, in which the heat is dissipated from the piston apex to the piston ring, and from the piston ring to the valve, cylinder valve. And basically, it supports the piston so that it will not come more in contact with the cylinder liner. And also, it is used to control the supply of the cylinder oil to the cylinder valve. Is it true? Last one, I think I'm confused in last.
सिलेंडर ऑयल टू
Is it okay?
क्या
It is used to control the supply of the cylinder oil to the cylinder liners, because the last in the there are three piston rings, right? Right. So the last piston ring, it is an scrubber, or it
एक
is also
कंप्रेशन
called
रिंग
as,
रहता है और एक पिस्टन रिंग्स रहता है ना पिस्टन रिंग कंप्रेशन टाइप्स।
उसके तीन रिंग्स रहते हैं, तीन रिंग. तो
हाँ.
फर्स्ट जो रहता है वो कंप्रेशन रिंग रहता है. सेकंड जो रहता है उसको वाइपर रिंग कहते हैं. तो वो वाइप आउट करता है एक्सेस ऑयल.
हाँ एक्सेस ऑयल हाँ.
इट इज आल्सो कॉल्ड एज बैकअप कंप्रेशन रिंग. और द थर्ड जो रिंग रहता है वो उसको आई थिंक स्क्रबर रिंग और ऑयल कंट्रोल रिंग कहते हैं. स्क्रबर रिंग नहीं, वो सॉरी क्या बोलते हैं, स्क्रबर रिंग वैसा ही कुछ बोलते हैं.
एक सेकंड रुको मेरा नोट्स में है.
वेट मैं भी सर्च करता हूँ.
एक टू पिस्टन रिंग्स में टू टाइप ऑफ रिंग्स रहते हैं, एक कंप्रेशन रिंग और ऑयल स्क्रैप रिंग. ऑयल स्क्रैप रिंग होता है. कंप्रेशन रिंग क्या करते हैं, प्रिवेंट्स द गैस एंटरिंग एंड आल्सो ऑयल, मतलब ऑयल भी एंटर करने से रोकता है कंप्रेशन रिंग.
First ring, it is a compression ring. So compression ring prevent the leakage of the scavenge air from the combustion chamber. Second one, that is a wiper ring. So wiper ring, it is also called as a backup compression ring. So it wipe out the excess oil on the cylinder liners. And the third oil, that is also called as scrubber ring or oil control ring. I don't know
ऑयल स्क्रैप रिंग करके बोलते हैं, पता नहीं
scrapper ring, right. Scrapper ring. Oil scrapper ring or the oil control ring. So basically that spray the
it scrape the some oil from the cylinder wall and allow it to return into the oil sump through the radial passage in the ring. वैसे
मैंने ये रीड किया था कि it spray the fuel around the circumference of the cylinder wall.
circumference cylinder wall वही है.
Yeah.
और हाँ एंड इट विल मिनिमाइज द फ्रिक्शन भी वो मिनिमाइज करता है. एंड इट इज अनदर फंक्शन इज इट इज कूलिंग एंड लुब्रिकेशन. तीन फंक्शन है. पर जब मुझे लगता है जब भी वो पिस्टन रिंग का फंक्शन पूछता है ना, तुम इतना सब बोलने का ज़रूरत नहीं है. इतना मतलब it will increase the quantity of the heat transfer. Elasticity property will increases, improve the heat transfer from the piston to cylinder wall and maintain the air tightness between the piston and cylinder wall. इतना 4 पॉइंट बोला तो काफ़ी है. मतलब दिस इज अ कंप्लीट फंक्शन ऑफ द पिस्टन रिंग. अगर तुम्हें स्पेसिफिकली वो मतलब कंप्रेशन रिंग का बोलो वैसा बोलो तो तुम
हाँ मैंने पहले चार चार जो बोले थे ना वही चार आपने भी बताया बाद में.
हाँ
मैंने पहले चार बोले फंक्शन क्या होते हैं, देन
उतना ही काफी
मैंने
है. इतना ही काफी
हर
है.
एक का एक्सप्लेन किया अगर चाहिए हो तो.
हाँ अगर वो चाहे हो तो वो पूछ लेता है. मतलब पिस्टन रिंग बोले तो जनरल फंक्शन इज 4 ही है, 4 बोल दो. फिर वो स्पेसिफिकली अगर वो पूछेगा तो तुम बाद में बोल सकते हो. वैसे मुझे मेरे हिसाब से मतलब वैसे करना अच्छा है करके लगता है.
यही अच्छा रहता है, जो पूछा वही आंसर देने.
हाँ वही. एंड देन व्हाट इज हीट ट्रीटमेंट एंड व्हाट आर द डिफरेंट प्रोसेसेस ऑफ इट.
हीट ट्रीटमेंट सॉरी हीट ट्रीटमेंट
ये पूछा गया है एक बार बाद
ये
में.
पूछा गया है.
हाँ पूछा
यार
है.
बता रही ऐसे यही क्वेश्चन पूछे जाते हैं जो मैंने नहीं किया. नॉर्मली ये भी हीट ट्रीटमेंट प्रोसेस ही है ना.
हाँ नीलिंग नॉर्मलिंग. हाँ ये भी हीट ट्रीटमेंट प्रोसेस ही है.
तो हम ये बोल सकते हैं कि उसमें बोल ही सकते होंगे.
हाँ
व्हाट आर द हीट ट्रीटमेंट प्रोसेसेस.
हाँ वो बोल सकते हैं. अनिलिंग, नॉर्मलाइजिंग, टेम्परिंग, मार टेम्परिंग और कुछ है ना. हीट ट्रीटमेंट प्रोसेस यही है. और हार्डनिंग प्रोसेस में क्वेंचिंग वो सब आता है. मतलब वो ज़्यादा हीट करके सीधा वो इसमें मतलब पानी में डाल देते हैं ना, वो क्वेंचिंग बोलते हैं उसे. वो हार्डनिंग प्रोसेस. हीट ट्रीटमेंट प्रोसेस अनिलिंग, नॉर्मलाइजिंग, टेम्परिंग, मार टेम्परिंग वही आता है हीट ट्रीटमेंट प्रोसेस. और व्हाट आर द डिफरेंट प्रोसेस ऑफ इट. हाँ वही मतलब ही व्हाट इज हीट ट्रीटमेंट बोले तो हम वी विल हीट द ऑब्जेक्ट मतलब रिक्वायर्ड टेम्परेचर मतलब हाई टेम्परेचर तक हीट करते हैं और वी विल कूल इट डिपेंडिंग ऑन द रिक्वायरमेंट. मतलब एक बार ये देख लेना. मतलब मैं ऐसे ही बोल दिया.
मैं वो हीट ट्रीटमेंट का डेफिनेशन क्या है
हाँ वो
एक बार देख लेता.
इस रेक्टिफायर ये पूछा.
हाँ rectifier it is used to convert the AC voltage into the DC voltage, which is used in the alternator, because we cannot store the AC voltage in the battery. So whatever the AC voltage which is generated in the alternator that converts into DC and stored in the battery. There is a rectifier.
और पावर सप्लाई इन होम.
That is 220 to 240 volt at the 50 hertz of frequency. And on the ship I think 440 volt होता है और 60 hertz की frequency पे and 3 phase होता है.
ठीक है. हम रुका. What are the skills that marine engineer have?
Skills, so he should be good in math. Also he should have the good knowledge of geography. He should be good in communication skills, and he should be multitasking. And
वो छोड़ो बाद में देख
he
लेंगे.
should also have an habit of living in loneliness. Can we tell this?
नहीं बोला तो भी चलेगा क्योंकि तुम वहाँ टीम वर्क ही करोगे.
हाँ वही
ओके. और एक तुम हाउ टू अवॉइड कैविटेशन.
Basically, cavitation can be avoided by maintaining the NPSH available more than the NPSH required, and NPSH available can be increased by either increasing the power, increasing the pressure, or by decreasing the speed of the pump. And by basically NPSH available, cavitation can be prevented by selecting the proper size of pump. So pump should not be bigger or smaller for that application. Also by maintaining the clearance between the impeller and casing. So that should also not be more or the less. That should be proper. And also the cavitation can be prevented by ensuring that there is no low pressure region created at the suction set.
Which is the boiler used in ships and why and which is most efficient?
So basically, in the tanker, the water tube boilers are used, whereas in the bulk carrier, container, ro-ro ship, on this side of the ship, smoke tube boilers are used, whereas water tube boiler, the rate of evaporation is more. That's why efficiency is up to 90%,
Mm-hmm.
and smoke-free boiler efficiency is I think 75%, right? 75%.
What is water hammering?
Basically, when we suddenly try to bring the fluid whose velocity, when we try to bring the fluid at the rest, means the fluid whose velocity is more, if we try to suddenly change its velocity, then it causes this water hemorrhage.
Mm-hmm.
Or if we try to bring the water suddenly at the rest,
Mm-hmm. ठीक है
then that causes the water hemorrhage.
करेक्ट है. और how to generate electricity on ship?
So basically, on an onboard ship, the auxiliary engine is used, which is used to transfer the auxiliary engine crankshaft used to transfer the power to the alternator shaft.
Mm-hmm.
And when the on this alternator shaft, basically rotor is mounted, and this rotor rotates inside the stator.
Mm-hmm.
So basically, when this rotor rotates inside the stator, the rotating magnetic field is induced, due to which the AC current is induced in the stator winding.
Mm-hmm.
And the rectifier is used to convert this AC current into the DC current, and that is stored in the batteries. And basically, auxiliary means may I tell where the auxiliary engine is? What is the use of auxiliary engine? That also should I tell?
ऐसे बोलो, उतना मत बोलो. नेक्स्ट क्वेश्चन में why 4-stroke engine is used as an auxiliary engine?
4-stroke engine is used as auxiliary engine. The reason is that it is having more volumetric efficiency. The 4-stroke engine is having more volumetric efficiency, and its scavenging is also better. And its its stroke length is less. That's why the speed of the engine will be more.
ऐसे
The
मतलब
4-stroke engine, it is a medium speed engine, and the 4-stroke engine, it is a 2-stroke engine, it is a low speed engine, and the 4-stroke engine, it is a medium speed engine. So its stroke length is less. That's why the speed will be more. That's why more amount of the speed will be more amount of the power will be generated. But in the 2-stroke engine, we require more power.
मर्चेंट नेवी में है, उसको पूछा था मतलब वाई 4-stroke इज यूज्ड एज एन ऑक्सिलरी इंजन. उसने बोला था इट इज इजी टू स्टार्ट. एक तो है मतलब मेन इंजन को ज़्यादा टाइम चाहिए स्टार्ट करने को कंपेयर टू द 4-stroke इंजन. एंड फ्रीक्वेंसी
मैंने बताया था पहले भी.
हाँ भाई. और फ्रीक्वेंसी जो चाहिए ना हमें ऑक्सिलरी इंजन, मतलब ऑक्सिलरी इंजन मतलब क्या है, अदर देन द रनिंग द शिप, अंदर में जो लाइटिंग्स है उसको कंट्रोल करते हैं ना ऑक्सिलरी इंजन. उसको जो फ्रीक्वेंसी चाहिए वो हमें 60 हर्ट्ज चाहिए. और ये वो फ्रीक्वेंसी हमें 4-stroke इंजन से मिलता है. उसके वजह से हम ये ऑक्सिलरी इंजन यूज़ करते हैं.
ये आपने कहा ना कि पहले कि इजी टू स्टार्ट होता है. इसका रीजन ये है कि लुब्रिकेशन जो है वो 4-stroke इंजन का 50 मिनट बिफोर स्टार्टिंग द मेन इंजन, 50 मिनट बिफोर स्टार्टिंग द ऑक्सिलरी इंजन लुब्रिकेशन स्टार्ट करता है. और ये ऑक्सिलरी और ये मेन इंजन का जो होता है लुब्रिकेशन, वो 60 मिनट बिफोर स्टार्टिंग द मेन इंजन लुब्रिकेशन स्टार्ट किया जाता है.
ठीक है.
ये मरीन इनसाइड की वेबसाइट है ना, वहां पर पढ़ा था ये क्या होता है. मैं उसके स्टार्टिंग सिस्टम क्या होता है, उसके 10 स्टेप्स कुछ तो थे, उसमें मैंने पढ़ा था. मुझे और एक पूछना था, वो जो लूब ऑयल का टेम्परेचर होता है ना, वो 45 डिग्री सेल्सियस को होता है. ये मैंने उस पर पढ़ा था, लेकिन उसका जो वो प्रेशर होता है वो कितना होता है लूब ऑयल का? हाँ,
मुझे भी मालूम नहीं. आई हैव नो आइडिया.
ओके.
देन
And radar
एक
redirect
सेकंड,
the flow.
बोला अभी बोला हाउ शिप विल टर्न.
So basically, rudder, the sterner is attached to the rudder, and rudder redirects the flow of water around the sterner and change the direction of the ship. And the rudder it is controlled by the driving wheel, which is mounted on the bridge. And basically, the rudder turns the ship 35 degree port to the 35 degree starboard. And there are 3 types of the rudder: balance, unbalance, and semi-balance. ऐसा कुछ 3 types. There are 3 types.
ठीक है. ए नहीं, नो प्रॉब्लम ब्रो. मतलब मुझे भी लगता है तुम इतना अच्छे से आंसर दे रहे हो ना, मुझे भी लगता है तुम्हें हो जाना चाहिए वैसे.
हाँ, मुझे भी लगता है हो जाएगा, लेकिन वो उन्होंने कोई क्वेश्चन पूछने से की तो मुझे आता है. वो और एक और बोल दे
1 फीट बोले तो 30 सेंटीमीटर है.
3050 फीट तो 50 सेंटीमीटर क्या
1 फीट 30 सेंटीमीटर होता है. तुमने क्या बोला?
30 सेंटीमीटर होता है.
हाँ, 1 फीट.
ओके 1 फीट. 1 feet equal to
30.48 टू बी एग्जैक्ट, पर
वो
तुम
पॉइंट
लोग
का रहने दो क्योंकि
हाँ वही
इतना लोड हो गया है भाई
वही
ब्रेन पे।
नहीं 30
30
सेंटीमीटर ही पढ़ लो बस। और
1 और ये भी पूछते हैं शायद कितना हाइट आपकी कितनी हाइट मीटर में होगी, तो मेरी होगी 170 तो 1.7 मीटर होगी मेरी।
हम्म
1.7 मीटर होगी हाँ।
वही।
1 मीटर इज इक्वल टू 100 सेंटीमीटर होता है हाँ, तो बरोबर।
और डिफरेंस बिटवीन डीजल इंजन, डिफरेंस बिटवीन पेट्रोल एंड डीजल इंजन।
Basically the petrol engine compression ratio,
हम्म
it is 8:10, whereas
हम्म
diesel engine compression ratio it is 18:20. So
हम्म
compression ratio of petrol engine is less, that's why the stroke length will be less and the speed of the engine will be more.
हम्म
Whereas in the diesel engine, the speed of the engine will be less due
हम्म
to more stroke length. And in the petrol engine, the air fuel mixture takes place inside the carburetor. Whereas in
हम्म
the four-stroke engine, we do not use the carburetor.
हम्म
The air and fuel is directly injected into the combustion chamber.
हम्म
And in the in the petrol engine, we require the spark plug. In the uh, diesel engine, we do not require the spark plug.
हम्म
And in the petrol engine, basically, it works on the cycle, which is auto cycle. And diesel engine works on the diesel cycle,
हम्म
which is a constant volume cycle, and the auto cycle it is constant pressure cycle.
हम्म
And petrol engine requires the volatile fuel, whereas diesel engine requires a non-volatile fuel. And the pressure inside the petrol engine is up to 10 bar, whereas pressure inside the diesel engine it is up to the 35 bar. And the efficiency of petrol engine, thermal efficiency of petrol engine it is up to 26%, whereas for the diesel engine the thermal efficiency is 46%.
Okay. And
This is the difference.
to give feedback you have told all the answers but except वो थर्मोकपल को जो है ना वो सिम्स में पूछा गया था,
हाँ
वो थर्मोकपल को वो प्रिपेयर
ओके
कर
ओके।
दो उसके। और
थर्मोकपल,
और
हीट ट्रीटमेंट प्रोसेसेस,
हाँ हीट ट्रीटमेंट प्रोसेसेस, थर्मोकपल और व्हाट इज ड्रिलिंग वो जो है ना उसमें ये करो।
ड्रिलिंग का भी
और
हाँ
टेम्परेचर वर्सेस परसेंटेज ऑफ कार्बन का जो है ना वो कर्व, वो
हाँ
कर्व याद
कर्व
कर लो,
ओके।
मतलब उसमें सब कुछ है ये, वो एक बार देख लो। और कल मैं हीट ट्रीटमेंट प्रोसेस का वो क्वेश्चन पूछूंगा और थर्मोकपल का
ओके
जो
ओके
आज तुमने आंसर नहीं किया ना वो पूछूंगा। और हाउ थर्मोमीटर वर्क्स ये भी तुम्हें मिस किया था, ये
हाँ,
पढ़ लो।
हाउ द थर्मामीटर वर्क्स,
हाँ
उसका है क्या आंसर आपके पास?
वो
हाउ द थर्मामीटर
मैं
वर्क्स,
मैसेज में मैसेज कर दूंगा छोड़, वो एक
ओके ओके
आंसर है
चलो।
ना। और एक लेथ मशीन का मतलब पार्ट्स ऑफ द लेथ मशीन वो तुम
पार्ट हाँ,
मैं वो
वो
भेज
पार्ट्स
दूंगा
मुझे पता है लेकिन
वो।
बहुत मिस हो गया लेकिन मेरे।
हाँ लेथ मशीन में वो मतलब वो 2 गियर है ना वो सब, मतलब वो सारा वो
हाँ
जो
हाँ
लेथ का मैं जो इंटरव्यू के लिए प्रिपेयर किया था ना वो मैं भेज दूंगा बस। और एक
ओके ओके थैंक यू।
और एक हीट ट्रीटमेंट प्रोसेस का तुम हाँ बोल दिया ना। और एक हाँ थर्मोस्टैटिक एक्सपेंशन वाल्व वर्क्स ऑन एन आइसेंथाल्पिक प्रिंसिपल और
आइसेंथाल्पिक और
कंप्रेसर
कंप्रेशन
वर्क्स ऑन
आइसेंट्रोपिक,
आइसेंट्रोपिक, हाँ आइसेंथाल्पिक एक्सपेंशन थर्मोस्टैटिक एक्सपेंशन वाल्व एंड कंप्रेसर
आइसेंट्रोपिक
आइसेंट्रोपिक कंप्रेशन
कंप्रेशन
compression
राइट।
हाँ। और सेंसिंग बल्ब कंट्रोल्स द थर्मोस्टैटिक एक्सपेंशन वाल्व थ्रू द कैपिलरी ट्यूब विद
कैपिलरेटिव।
द हेल्प ऑफ कैपिलरी
और
ट्यूब।
और और मुझे 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 एक पूछना था, ये मुझे भी पता नहीं था कि जो हमारा घर में जो ये यूज होता है रेफ्रिजरेटर,
हम्म
तो उसका जो सिस्टम है और वीसीआरएस सिस्टम जो है वो सेम है ना? इंस्टेड ऑफ थर्मल एक्सपांशन वाल कैपिलरी ट्यूब यूज की जाती है,
हाँ कैपिलरी ट्यूब ही उसका
सही है
सेम है,
ना?
हाँ सेम है सेम है।
और बाकी का पूरा सभी सेम है ना?
हाँ सेम है और सब कुछ सेम है, पर इसमें मतलब सी वाटर यूज़ करते हैं मतलब कंडेंसर को कूल करने के लिए। और इसमें मतलब कूलिंग डिवाइस कंडेंसर कैसे कूल होते हैं मुझे भी मालूम नहीं इसमें रेफ्रिजरेटर
ये भी पूछा गया था कुछ कौन सा रेफ्रिजरेंट यूज करते हैं एसी में।
एसी में।
आइसोब्यूटेन
हाँ हाँ
हाँ आइसोब्यूटेन नहीं, फ्यूरॉन एंड फ्यूरॉन यूज किया जाता है। फ्यूरॉन होता है R12 R22 एंड फ्यूरॉन होता है R410। देन ये कैपेसिटी क्या होती है नॉर्मल रेफ्रिजरेंट की? रहती है 1.1 टन टू 1 सॉरी 0.1 टन टू 0.3 टन रहती है। और कौन से रेफ्रिजरेंट यूज किए जाते हैं वो भी पूछा था।
रेफ्रिजरेंट तो R134A यूज़ करते हैं इसमें मतलब शिप में R134A, नहीं तो R400 404 है, और 408 410, और यही
कौन से आर 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 11 यूज किया जाता है? मैंने सुना था R11 यूज किया जाता है
R11 पहले
आजकल।
यूज करते थे, अभी वो क्लोरीन का मतलब अभी
एक
मार्कोल का
सेकंड से,
आ गया
आर
ना।
फोर हंड्रेड R410A यूज किया जाता था, R717 यूज किया जाता था, R410A यूज किया जाता था, R1234ZE ये यूज किए जाते थे सिंस 2014, बट सिंस 2020 रेगुलेशन इट इज मस्ट यूज हाइड्रोक्लोरोफ्लोरोकार्बन।
हाँ, HFC यूज करते हैं, और उसमें R134 ये कॉमनली यूज्ड है, और R404 R408 R410 ये यूज
ये
करते
जो है
हैं।
ना R134A,
हाँ
ये हाइड्रोफ्लोरोकार्बन है ना?
हाँ, हाइड्रोफ्लोरोकार्बन ही है।
ये अभी यूज नहीं ना करते, क्या करते यूज?
ये यूज करते हैं अभी भी।
ओके ओके। और एक क्वेश्चन था, बताए क्या?
और
मैंने सही से
इसमें
सुना था,
मतलब
मुझे पता नहीं
एंग्लो
है।
ईस्टर्न में कोई एक इंटरव्यूअर यही पूछता है, मतलब R134 है ना, उसका इवापोरेटर टेम्परेचर क्या रहता है, वो -18 to -20, वो
-26 रहता है ना?
-26 उसका मतलब हाईएस्ट पॉइंट है, मतलब एटमॉस्फेरिक प्रेशर में उसका मतलब बॉइलिंग पॉइंट कुछ -26 डिग्री सेल्सियस है, पर इवापोरेटर में उसका टेम्परेचर -18 to -20 है। मैं चेक किया था इसका
उस दिन मैं ज्ञान का एक वीडियो देख रहा था, तो उसने बताया
हम्म
कि इवेपोरेटर कॉइल जो होती है, तो
हम्म
इसमें जो फ्रीजर का सेक्शन होता है, वहां पर जो टेम्परेचर इवेपोरेटर कॉइल का होता है वो -18 to -20 रहता है।
हाँ
ओके। और जो हाइड्रोफ्लोरोकार्बन होता है, जिसमें
हम्म
इवेपोरेटर का जो इवेपोरेटर कॉइल में जो टेम्परेचर रहता है उसका,
हम्म
तो वो रहता है -26 डिग्री सेल्सियस। वो
हम्म
उसने बताया था, ऐसा मैंने सुना है, तो उसने बताया, कहाँ से लिया रेफरेंस मुझे भी पता नहीं।
रुक R134 एक अभी चेक करें। ज्ञान ये भी
डिपेंड अपॉन टेम्परेचर भी
ज्ञान
रहता
ये भी बताया था, जब हम इसमें मतलब क्या वेजिटेबल का सेक्शन अगर वैसे कुछ रहता है ना, उसमें -4 डिग्री सेल्सियस रहता है। अगर
नहीं नहीं,
मीट रूम
उसका
में
रहता है 4 डिग्री सेल्सियस,
हाँ वही
-4 नहीं रहता, 3 to 5 डिग्री सेल्सियस रहता।
ना। अभी मैं R134 का ए का निकाला हूँ। एंड इवापोरेटिंग टेम्परेचर रेंज फ्रॉम -20 डिग्री सेल्सियस टू -10 डिग्री सेल्सियस, ये सर दिया है,
ओके
विथ कांस्टेंट कंडेंसिंग टेम्परेचर ऑफ 50 डिग्री सेल्सियस,
ओके।
ऐसा दिया है।
यार कुछ भी पूछ लेते हैं, उनका क्या
वही
है, क्या
मतलब
भरोसा।
-20 to -10 उस रेंज में होता है करके यहाँ अभी मैं
ओके।
देख रहा हूँ वैसे। ठीक है।
भी पूछा था शायद कि फिजिबल प्लग कहाँ माउंटेड होता है इसका, बॉयलर का और कंप्रेसर का, ये क्वेश्चन पूछे थे। और भी बहुत सारे
ये
क्वेश्चन
कॉमन
पूछे थे।
क्वेश्चन है ना, वो फ्यूजिबल प्लग मतलब इसमें कुछ बोला था।
कंप्रेसर में एट द डिस्चार्ज साइड ऑफ कंप्रेसर, वो नियर द एयर बॉटल रहता है क्या?
हाँ हाँ।
और जो बॉयलर रहता है उसमें अबाउ द फर्नेस इनसाइड द शील्ड ऑफ बॉयलर
हम्म।
फिटेड फिजिबल प्लग।
मतलब अंदर ही रहता है ना उसमें, मतलब वो मेल्ट हो जाता
हाँ,
है
इनसाइड द शील्ड ऑफ बॉयलर
इनसाइड
एंड
द शील्ड
अबाउट
ऑफ
द।
बॉयलर। हाँ वही।
हाँ।
हम्म, ठीक है। और तुम्हारा कुछ गलती वैसा नहीं है, मतलब सब कुछ ठीक है वैसे कुछ।
देखेंगे यार क्या होता है।
ये हो जाता है उतना
क्योंकि
सोच लो।
बताइए क्या, और मुझे एक बात बताना, क्योंकि मैं अभी आज मुझे वो साइकोमेट्रिक का भी टेस्ट का आया था मेल, तो
हम्म।
उसके साइकोमेट्रिक टेस्ट के लिए भी कोई टिप्स दे दो थोड़ा बहुत, या क्या
साइकोमेट्रिक
करना
टेस्ट
होता
है,
है?
उसमें ना तुम
हाँ।
मतलब न्यूट्रल मत लगाओ, मतलब लीस्ट अग्री अग्री मतलब न्यूट्रल, वो वैसा रहता है ना, रेंज 4 ऑप्शन रहते हैं टोटल, उसमें मतलब तुम न्यूट्रल मत लगाना। वैसे न्यूट्रल कितना होता है उतना कम लगाओ। और मैं कैसे साइकोमेट्रिक टेस्ट दिया था मालूम है, मैं सोचा मैं अपने आप को, मैं कोई स्टूडेंट को सेलेक्ट कर रहा हूँ, मतलब मर्चेंट नेवी में उस इंसान में क्या क्या क्वालिटीज़ होना चाहिए, वैसे मैं दिमाग में रख के मैं वैसे आंसर दिया था, उतना ही।
रिस्क बहुत भी ज्यादा हाई नहीं लेनी चाहिए और बहुत कम भी लेनी नहीं चाहिए, मॉडरेट रिस्क होनी चाहिए।
हम्म
डिसीजन मेकिंग स्ट्रांग होना चाहिए। ये
हम्म
भी मैंने सुना था। ये मैंने अभी सर का वीडियो देखा था, अपने
हम्म
नील
हम्म
सर का।
हम्म। और बहुत
बहुत
सारे
अच्छे से
क्वेश्चन
बताया
कैसे
उन्होंने।
रहते हैं, मैंने ही दिया था ना वो एंग्लो का, जब साइकोमेट्री में डिड यू ट्राई टू कमिट सुसाइड, वैसे वैसे वाला ही रहता है। वही वही सच
Strongly
में,
disagree.
यू आई विल ऑफन गो टू द डिप्रेशन, अग्री डिसअग्री, और स्ट्रांगली अग्री, स्ट्रांगली डिसअग्री, वैसा वाला, वैसे वाला ही
मैंने
मतलब। हाँ,
वो
स्ट्रांगली
वो
डिसएग्री
तो
वो
आपने
तो
आपने
सेल्फ एक्सप्लेनेटरी
हाँ
है।
हाँ हाँ
हाँ, स्ट्रांगली डिसएग्री वैसे मतलब इन इन सारे क्वेश्चन को ना स्ट्रांगली डिसएग्री मार्क कर देना वैसे। और कितना होते उतना न्यूट्रल वाला जो रहता है ना वो मत लगाओ।
उसको अवॉइड करने की।
हाँ, और एक दो क्वेश्चन कैसा रहते हैं, एक सीधा से पूछता है और एक घुमा फिरा के वही क्वेश्चन पूछता है। अगर तुम वो दोनों क्वेश्चन को मतलब तुम डिफरेंट आंसर रहा ना तो रिजेक्ट करता है, मतलब बहुत ध्यान से तुम
हाँ
अप्लाई
हाँ।
करना चाहिए वैसे।
क्योंकि मैंने एक बार ग्रेड का दिया था,
हम्म
उसमें तो अच्छे थे, ठीक ठाक थे।
हम्म।
तो इसलिए पूछा, क्योंकि मुझे भी पता नहीं सिम्स का कैसा रहता है, क्योंकि अगर एक्सपीरियंस हो किसी को
सिम्स
तो
का
उसको
मतलब अभी
पूछना चाहिए।
इंटरव्यू होने के बाद ही मतलब साइकोमेट्रिक होता है ना?
नहीं पता है क्या क्या है।
हम्म
मुझे भी ऐसा ही लगा था कि इंटरव्यू के बाद साइकोमेट्रिक होगा।
हम्म।
लेकिन मुझे आज मेल आया कि मुझे 31st को 10 बजे साइकोमेट्रिक टेस्ट देना है
हाँ हाँ, फिर
ऑनलाइन।
मतलब लोग ज़्यादा डाल रहे हैं शायद सिम्स को एप्लीकेशन, मतलब साइकोमेट्री में ये थोड़ा बंदे को
हाँ
रिजेक्ट रिजेक्ट करने के लिए ये सब बोल रहा है।
हाँ वही तो। क्योंकि कितना है पता है क्या, 60, आई थिंक
पहले जैसे मैं मुझे
600 से
मालूम है,
ज्यादा।
पहले पहले तो साइकोमेट्रिक एक फॉर्मेलिटी जैसे ही था, मतलब सबको सेलेक्ट करते थे। अभी इससे पहले
हम्म,
ही डाल रहे तो मुझे लगता है थोड़ा सीरियसली ले रहे हैं वैसे साइकोमेट्रिक टेस्ट।
हाँ ऐसा भी हो सकता है, पता नहीं क्या है। नहीं हाँ, मैंने सुना था, शायद राकेश भी कह रहा था कि वो
नहीं, एक मिनट।
था।
वही
हाँ बोलो बोलो।
वही मतलब, और तुम्हारा गलती तो कहीं नहीं था वैसे, बहुत अच्छे से ही आंसर दिया हो वैसे, सिर्फ उतना ही मतलब थोड़ा करेक्शन करो वो। ठीक है, ओके ब्रो, थैंक यू।
थैंक यू थैंक यू थैंक यू।